seems like it would be a response to XX chromosomes, but she has XY chromosomes. So I guess I'm wondering, like, is there a spectrum?
Oh, for sure, for sure. There's a lot of overlap between different brains and different people. I think what we see as scientists that on average, like the average male brain is somewhat bigger than the average female brain.
Oh, isn't that just a stereotype?
No, it's true. Male brains with more androgens like testosterone are generally bigger.
Okay.
But then there's everything else in between. So yes, it's never black and white. Like a lot of people ask me if I give you a brain scan and you just look at the brain scan, can you tell me if that brain belongs to a man or a woman? I was like, no, of course not. Yeah, no, you cannot do that.
But then, how do you know? When's the moment when you're like, oh yes, this is female, or oh yes, this is a male brain?
In my experience, the most defining feature is the change over time, starting in our late 40s. So instead of looking at the anatomy of the brain or the volumes or the size of the brain, what really changes is the functionality of the brain. So women's brains tend to show declines in brain energy levels around menopause, whereas these declines are not seen in men of the same age. So if you give me a brain scan and you don't tell me who the scan belongs to, but I can see brain energy levels, let's say in a person's like 45, 48, women are much more likely than men to have lower metabolic activity
In their brains.
in their brain. Yes, in their brain.
Okay, so as a woman barreling towards her late 40s, that gives me great pause because essentially what you're saying is that a man my age is pretty much gonna have the same brain his whole lifetime. But as a woman, my brain is going to go through a change because my body responds to hormones differently, correct?
Yes, yes, and it's not just menopause. I think we tend to we think of aging as a linear phenomenon, but it
neuroscientist Lisa Mosconi. Her latest book is The XX Brain. You can see her talk at TED.com. On the show today, the biology of sex. And so far, we have talked about chromosomes, gonads, hormones, brains, but there is so much we don't know about how we end up with sex that we do. And we may not find out for a long time.
Looking more and more into the research, there are so many open questions, so we're trying to understand now, but there's no smoking guns yet at all.
This is structural biologist Carissa Sundman-Watson. She works at Los Alamos National Laboratory, and she's asking some of those questions that may change how we see biological sex in the future. Before turning to biology, Carissa studied lots of things.
I was really inspired by Star Wars in the beginning, and I wanted to know astrophysics, so I did that. I started getting into chaos theory, complex systems, and nuclear theory, then I did laser fusion, but then when I became a principal investigator at Los Alamos, my heart was really with biology, and so I was obsessed with the origin of life.
And the reason why Carissa went from studying the stars to studying what determines biological sex is a personal one. Here's Carissa on the TED stage.
When people learn that I'm a woman who happens to be transgender, they always ask, how do you know you're a woman? Well, as a scientist, I'm searching for a biological basis of gender. I want to understand what makes me, me.
Carissa was assigned the male gender at birth. About a decade ago, she transitioned to female, but her new life was sometimes Eve.
I knew I was a woman on the inside, and I wore women's clothes on the outside, but everyone saw me as a man in a dress. I felt like no matter how many things I tried, no one would ever really see me as a woman. In science, your credibility is everything, and people were snickering in the hallways, giving me stares, looks of disgust, afraid to be near me. I remember my first big talk after transition. It was in Italy,